When I normally talk about multiplying binomials together, I usually talk about in terms that actually apply to more than just binomials. Normally I just say you multiply everything in the first parentheses by everything in the second parentheses, because that is what we're doing here. But we often don't take the time to talk about why that works the way it does. Really, we're using distributive property here. And so I want to multiply this x by this whole parentheses here. So that's going to have to multiply by the x. Basically, that x minus 6 is distributed to that x. Same thing with the 10. And so when I then multiply that x by both of these, the x and the minus 6, and then the plus 10 by the x and the minus 6, notice then I have actually multiplied everything in the first parentheses by everything in the second parentheses. That's why it works the way it does. It's just that we can do it with even more than just binomials. We can do it with trinomials and all sorts of other polynomials in there. And so if I then distribute in the x and distribute in the 10, we end up with this line. And this really is the line that many of you will have started at, because you didn't necessarily feel the need to write it out this way first, but you certainly can. But once we're there, notice we aren't quite done, because I know it says expand, but we still need to simplify our answer. The expansion part gets rid of the parentheses. But in order to then totally simplify it, I'm going to combine the like terms, which is going to be the minus 6 plus the 10. So then this is actually the final expanded answer. Basically, expansion and factoring are opposites of each other. Expansion gets rid of the parentheses, factoring puts in the parentheses. Repeat the process with the second one. All right, so doing the second one, we can actually approach it the same kind of way, where I'm saying I'm going to multiply the 8x to everything over here, and then I'm going to multiply that minus 5 by everything over there. And I kind of like writing it this way first, not because you necessarily have to, because I think you know the routine, but because this brings back what we did yesterday, right? Because remember yesterday I was giving you something that looked like this, and then having you factor it into that. And so it just creates a little bit of symmetry, and of course seeing that we're doing the same kind of stuff is always good. All right, so now we can go ahead and do that distribution. So multiply the 8x in, multiply that negative 5 in, and then we can go ahead and combine like terms. Now as you do that multiplication, keep track of your x's. Remember that x times x will give us x squared, and that anytime I'm multiplying by an x, I still have an x in there. All right, so I can combine the like terms here. Negative 88x and a negative 15x. Well, those combine to a negative 103x. And so then this is our final answer. All right. Now, the reason why we started off with this expanding is actually because it's going to lead us into today's new work. Because today we're going to be starting actually with something that looks like this. And we're going to go through a whole process of going backwards to get something that looks like that. And so you'll notice then it's basically the same idea as what we did up here. Because of course you already know how to factor those, right? So if I take a look at this sort of a problem, where I have the x squared plus 4x minus 60, I could factor those because I'd say what adds to the middle number multiplies to the last number. And when I did that, remember that, like in this particular case, what adds to 4 and multiplies to negative 60 is negative 6 and positive 10. Notice that when I found those two numbers, basically what I was doing is I was breaking up this 4x into two pieces that then became this kind of a factored form. We're actually just doing this very simplified form of something that we're going to be doing later today. Just today we got to go through all the steps, because since we got a 24x squared, it does make it a little bit more complicated and a little bit more involved. And so in order to figure this out, I want you to notice something here. And this isn't like required knowledge, but if you're curious why the method that we're going to be going through today works, I can kind of tell you right now. If I take a look at the last problem that I just did, and how we ended up going about that one, I got that 103 in the middle. The trick with it, really, if we're going to factor that, was knowing that it's going to become a negative 88 and a negative 15. That's what I break the 103 into. Now, how did I know that? Well, if I take negative 88 and multiply it by a negative 15, I get 1,320, which means nothing at the moment. But if I then take the 24 times the 55, so you notice if I multiply the inner ones, I get 1,320. If I multiply the outer ones, the 24 and the 55, I get 1,320. They equal the same thing. So basically, in order to know what numbers I break this into here, I know that they added to negative 103, that's familiar, and they multiply to 24 times 55, whatever that gives me. So I could actually have figured out that 88 and 15 by saying what two numbers multiply to 1320 and add to negative 103. And that's what we're going to do here. So I'm going to start you off with this problem. Now this one, just write it down and I'm going to walk you through the steps. I've chosen this one because I know this is not a problem with these specific numbers that you will see for a long time, because the numbers just end up being a bit big and unwieldy. Alright, so the first thing we need to do in order to factor this is we actually do need to figure out what A times C is. And so that's 88 times negative 108. Now, when I say A times C, that's going back to those notes we took last week on a quadratic, where we saw the general form of a quadratic is ax squared plus bx plus c. Often when we're talking about quadratics, we talk about a, b, and c. That's what we're talking about. So a is whatever number is in front of x squared. C is whatever number is hanging there on the end. Alright, so I multiplied a times c, which gave me negative 9,504. Remember how I said that this was a much bigger problem that you're going to have to deal with on your own for a while? This is why. Because I need to now find two numbers that add to b, that is, add to a positive 3, and multiply to ac, which was 9,504.
I know.
Yeah, that's not fun, right? But if we can find that combination, it actually tells us what the combination is that we need. It's just, I'm not going to make you do that on your own right now because it's a pain. We'll save that for later after you've done lots of experience with it, you're comfortable with it, and it's either faster for you, or we've at least talked about another method that you can use to find that combination easier. So today I'll just tell you that the combination is negative 96 times 99. Notice, those two numbers, they add to 3, and if you multiplied them, yes, they would give you negative 9,504. So why did I want that? Because that then lets me break up my b value. That lets me break up positive 3x into negative 96x and a positive 99x. So this is what my next line of work looks like. It's the same as the first, except I broke up my b value. And I note over here that the order does not matter. I'll actually show you a little bit more specifically why later. But for now, just know that if you had written this as 99x minus 96x, you'd still end up with the same final answer that we're going to come up with here. Alright, so now that I've broken that up, the next step is that we're going to be doing some factoring. Now remember those problems that we were factoring yesterday? Where you would have something like, you'd have something out front of a set of parentheses, and then you'd have the same set of parentheses again. That's what we're going to be getting here. This is what it ends up looking like. Now I'll give you a chance to write down the work, and then we'll explain how we get this. And so you'll notice over here a description about what we're doing. We're factoring out the greatest common monomial first from terms 1 and 2. So I'm going over here to the first two terms. Actually, I should do it up here. And I'm looking at those two terms and saying, what can I factor just out of those two? And you notice I can take an 8x out of both of those. And hence the 8x that I have right there. And when I factor that out, it leaves me with 11x minus 12. I then do the same thing for terms 3 and 4. So I go over here to term 3 and term 4, and I say, what can I factor out of those two? The last two terms. And you notice I can pull a 9 out of both of those. And so that's where this 9 came from over here. And when I factor that 9 out, I end up with 11x minus 12 on the inside. Notice that when I did that, inside the parentheses for both of them is 11x minus 12. If we have done everything correctly to this point, inside of the parentheses will be the same. Because we can't do it if they're not the same. Because the last step is that we now factor that. Remember that work we did yesterday where I gave you something that looks like that? And I said to factor it? This is why. Because I was wanting to get you ready for handling this so that this part didn't seem weird or funky. So I factor out that 11x minus 12 and we're left with 8x plus 9, because notice the 8x and the plus 9 is what's left outside, and the 11x minus 12 is what was inside. That is then our final answer. Now, that is the answer for this one, but you could have written it slightly differently. You could also have written the order flip-flopped. You could have written 11x minus 12 first, and the 8x plus 9 after that. That would be perfectly fine. But notice the signs go with the numbers. So it's still a minus 12 and it's still a plus 9. But the order of the individual parentheses, that doesn't matter. Now, one last thing on this. Notice I say down here, if you had split up this line differently, so if you'd done 99x minus 96x instead of that minus 96 plus 99, we would end up with the same answer. What would be different? And no, you don't need to know this strictly speaking, but you might be curious. If I flipped these around and done the order backwards, inside the parentheses actually would have been the 8x plus 9, and then the numbers outside would have been the 11x and the 12. That's the only difference it would make, so that's why we'd still end up with the same answer. So now, I want you to go ahead and do this one now. We're going to factor it out, but you've seen the process, you've taken notes on what the process looks like, so theoretically you could go ahead and do it. You notice the numbers are a lot prettier now. So for doing this one, go ahead and start working it through on your own. If you hit a point where you're not sure what to do, hit the pause button there, because I'll be putting up little hints along the way showing this is what you should have done first, this is what you should have done second, all the way down, so that if you get stuck, we can get you unstuck. So first step, remember we have to figure out what AC equals. So do A times C, which in this case is 15, times 8. So that equals 120. Now we need to use the 120. So remember that I find that 120 because my goal is to figure out what two numbers multiply to the 120, but add to my B value, which is negative 22 here. So I'm looking for that combination, what adds to negative 22 and multiplies to 120. All right, so the nice thing is that in this case, 120 is a lot better than 9,504, right? This is more typical of the kinds of numbers that you will be seeing on these problems. As you go through these, 120 is going to seem like an easy number here pretty soon. And so this is more kind of the numeric range that you're going to be looking at for a while. I'm not going to be giving you the really big numbers, at least for a while, remember. And then you'll have other techniques and other skills you can use if we get that far with it. All right, so I need two numbers that add to negative 22, multiply to 120. That is going to be negative 12 and negative 10. And so remember that I take those two numbers and I use them to split up B. So now rewrite your equation with the split up B. And so I chose negative 12 and negative 10 because they add to negative 22. So my negative 22 now gets split into two pieces. The 15 and the 8, they just stay the same. And then now that you've done that, remember that the goal at this point now is to be able to factor the first two terms and then factor terms 3 and 4. So go ahead and do that factoring. And notice, keep the x coefficients positive. We'll see why here in a moment, but yeah, keep those coefficients positive on the x's. So when I look at factoring that first two terms, I'm looking at the 15x squared and the 12x. Well, out of 15 and 12, I can pull out a 3. And they both include x's, so I'll actually pull out a 3x there. And for the second part, well, there, looking at the 10 and the 8, I can divide them both by 2. But you notice that if I do that, negative 10x divided by 2, that's going to give me a negative 5. And I want to keep those x coefficients positive. So instead of pulling out 2, factor out negative 2. So when we do that, this is what we're looking at. And when we can see this result, it makes it a little bit easier to see why I need to keep the x coefficients positive. Because when I first factored out that 3x, I ended up with 5x minus 4 inside of the parentheses. If I had factored out a positive 2 instead of a negative 2, I'd have negative 5x plus 4 here. It wouldn't be the same. If those parentheses are not the same, I can't factor it from here. And that's what I have to do next. And so, in order to keep them the same, we keep that x coefficient also the same. All right, so now that I got it to here, your last step, factor it. Factor it using those same skills, same techniques as what we saw yesterday. In this case, that means taking that 5x minus 4 out of both terms. And so then this is our final factored form, our final answer.